Okay, question 13. A curve C has equation y equals x cubed minus 3x squared. A cubic graph, so find the stationary points. We're expecting two stationary points for this graph because a cubic graph will have the two terminal points, I expect, in this case. So stationary points are points, if I just sort of have a bit of a generic sketch here, points like this coordinate here and this coordinate here, where at those points the gradient is 0 because the tangent to those curves at those exact points are horizontal, so that means there's no steepness and the gradient is 0. So this one wants to find the stationary points. Now, first of all, to find the stationary points, we need to find the gradient, or at least an expression for the gradient, which can be found by differentiating. So for part A, first thing you're going to do is dy by dx. You're going to differentiate that equation you have there to give you 3x squared minus 6x. So for that gradient, well, that's an expression for the gradient at any point along this curve here. So stationary points happen twice, and they happen when the gradient is 0. So let's just take that expression for the gradient and put it equal to 0. And if I factorize this now, I will have 2x coordinates, hopefully, because it's a quadratic. Factorizing this, 3x can be taken out, x minus 2 inside the bracket, which means that either 3x equals 0 or x minus 2 equals 0. So you get x equals 0, x equals 2, which means that the coordinate here is 0 something, and the coordinate here is 2 something. But obviously we need those somethings. We need the y coordinates. I'm going to go up here now, and I'm going to sub both into my original equation, not the gradient, because it's not going to give you anything. I'm going to sub both into y equals x cubed minus 3x squared. So it is y equals 0 cubed minus 3 times 0 squared, which obviously is 0, which means that that coordinate there is 0, and we also get y equals, what was the other one, 2, so it's 2 cubed minus 3 times 2 squared. 2 cubed is 8, 3 squared 4, 8 minus 12 minus 4. Okay, so we have 2 minus 4 as your other coordinates. I've written them in this diagram over here, but obviously you should be doing them in terms of like actually writing them as full coordinates in your answer. So those are the stationary points. We haven't done this bit yet where it says determine their nature. Remember, one is going to be a maximum, one is a minimum. Now, I've sort of assumed the shape of the graph there because I roughly know in my head what that's going to look like, but you need to prove it. You need to determine the nature of those stationary points, which one's the max, which one is the min. So I find that from finding d squared y by dx squared, the second derivative. So if I differentiate this expression again, and I get 6x minus 6, if I sub both the x coordinates into that, they will tell me one at a time which one is the max, which one is the min. So let's sub in 0, and let's sub in 2, and you end up with minus 6, and you end up with 6. Negative 1 means it's a minimum. So that means that the coordinate of 0, 0, or what should I say, a minimum? Sorry, maximum. That is a maximum. And 12 minus 6, that's positive. So that means that the other one, 2 minus 4, is a minimum, which means my graph makes sense. Over here, my little sketch over here makes sense because this point, this turning point here, this stationary point of 2 minus 4 is the bottom. It's the turning point on the way down, then turning back up, and then 0, 0, obviously the maximum being the opposite. It doesn't have to be the tallest point on the graph, because obviously this graph up here is going to keep on going a bit higher, but it's the maximum stationary point. Okay, part B, I sort of plan to do as we go along here. Part B wants a sketch of C, clearly indicating the stationary points and the points where the curve crosses the coordinate axes. Well, I'm just going to sort of add axis. Sorry, my diagram drawing skills not so good without a straight line tool. What's going on there? So we have x and y axes. That's roughly what it's going to look like, because it's 0, 0 is obviously there. 2 minus 4 down here. Not quite finished there because it wants the points where it crosses the coordinate axes. Oops, supposed to underline, not draw through that. Coordinate axes. That includes this coordinate here, which we have not yet found out. That coordinate there is when the original equation is equal to 0, because the y coordinate here is equal to 0. So that is when I have 0 equals x cubed minus 3x squared. Okay, now that means that I can find out what x is by hopefully factorizing or rearranging this. Now, it's not, you might be thinking, oh, it's not a quadratic. How do you factorize that? Well, x squared is common to both, so I can take that outside the bracket, and you end up with this, which means that either x squared equals 0, and of course, you square root 0, you just get 0. Plus or minus 0, doesn't matter, it's the same point. That is what this coordinate is here, okay? And the other one means x equals 3, according to this bracket. So that is definitely the coordinate 3 something. Now, obviously, to get the y coordinate, I need to sub 3 into my original equation, which is y equals x cubed. That's 3 cubed minus 3 times 3 squared. I just realized, because I'm an idiot, I was subbing that in to get 0, but obviously it's 0s on the axes. Sorry, my mistake. Wasted a bit of time there. So we get 3, 0. Anyway, that's just proving it. Let's think of it like proving that that is 0. There we are. That's the sketch of what it should look like for part B. On to part C. Without performing the integration, state whether the integral between 0 and 3 of the curve is positive or negative, given a reason for your answer. Now, there's the important point. 0 and 3. Between 0 and 3. I'm going to sort of shade on the graph the area that it is talking about. It's talking about this area here. That's underneath the curve. That's underneath the x-axis. Therefore, it's negative. So the answer is negative. And then you can say something like area underneath x-axis, or something also as valid.